Dr. Wahyudi. I also would like to say welcome to Aceh, especially to Ar-Raniry State Islamic University Banda Aceh. And the Honorable, our invited speaker, Professor Roberto Araya, Christy Mordos as a consulate USA, and Mayasari MSE. The Honorable, the Head of Chemistry Education Department, Ibu Sabarni MPD, and the Honorable, all the lecturers in the Chemistry Education Department. And also, we welcome all of the presenter and audience to our big event, the second International Conference on Chemistry and Chemistry Education. Well, now we start in the first agenda. Let's start this agenda by reciting Basmalah together. Bismillahirrahmanirrahim. Step on the following agenda is reciting the Holy Quran, who will be recited by Ustadz Takdir Ferizal SPDI. He is an international Qari. To Ustadz Takdir Ferizal SPDI, time is yours.
السلام عليكم ورحمة الله وبركاته. ولكل وجهة هو موليها فاستبقوا الخيرات أينما تكونوا يأتي بكم الله جميعا إن الله على كل شيء قدير. ولكل وجهة هو موليها فاستبقوا الخيرات أينما تكونوا يأتي بكم الله جميعا إن الله على كل شيء قدير. بسم الله الرحمن الرحيم. وإذ تأذن ربكم لئن شكرتم لأزيدنكم ولئن كفرتم إن ولئن كفرتم إن عذابي لشديد صدق الله العظيم.
Followed by Salawat Badar, I would like to invite all of you to stand up.
صلاة الله سلام الله على طه رسول الله صلاة الله سلام الله على ياسين حبيب الله صلاة الله سلام الله على ياسين حبيب الله توسلنا ببسم الله وبالهادي رسول الله وكل مجاهد لله بآل البدر يا الله صلاة الله سلام الله على طه رسول الله صلاة الله سلام الله على ياسين حبيب الله. السلام عليكم ورحمة الله وبركاته.
The third agenda is singing Indonesian national anthem and followed by Hymne Aceh, who will be led by our sister to Miss Putri Najwa. The floor is yours.
tiga membela bangsa. Mulia nanggroh, mulia dum syuhada, metuah bijih Aceh mulia. Ya Tuhanku, rahmat bersampo, negeri Acehnya bermulia. Rahmat melimpah, metuah aso, are kekamo bersejahtera. Aceh masyhur, makmungan megah, sabeta jaga Aceh mulia. Bekaden Aceh melimpah bago, bermesaho mesyedara. Besapepakat, besabohnya menemat syariat Islam ke hukum bangsa. Ya Tuhanku, rahmat bersampo, negeri Acehnya bermulia. Rahmat melimpah, metuah aso, are kekamo bersejahtera. Aceh masyhur, makmungan megah, sabeta jaga Aceh mulia. Aceh masyhur, makmungan megah, sabeta jaga Aceh mulia.
Wa sahbihi ajma'in. Puji beserta syukur tidak henti-hentinya kita ucapkan atas rahmat dan karunia yang Allah limpahkan kepada kita sekalian, terutama adalah rahmat iman, rahmat sehat, sehingga pada hari yang berbahagia ini kita dapat hadir bersama-sama untuk International Conference yang dilaksanakan oleh Program Studi Pendidikan Kimia. Selawat bahaturkan salam kita sampaikan ke junjungan alam Nabi besar Muhammad sallallahu alaihi wasallam. Atas perjuangan beliaulah kita dapat menikmati, merasakan indahnya kehidupan di muka bumi ini. Kata-kata penghormatan kami dan yang kami muliakan, yang pertama adalah kepada Bapak Ibu keynote speaker ataupun narasumber kita yang sudah berhadir pada kegiatan International Conference ini. Yang pertama ada Ibu Nurjahan Ahmad dari University Science Malaysia. Selamat datang Ibu di Aceh, di kampus UIN Ar-Raniry. Mudah-mudahan atau mungkin ini yang baru pertama Ibu ke UIN. Alhamdulillah. Ibu sabar dan tim nanti, ini kami belum tahu apakah sudah dibawa raun-raun jalan-jalan ya Ibu Nurjahan. Selanjutnya yang kami hormati dan kami muliakan adalah Bapak Dr. Wahyudi, Direktur Semolek. Selamat datang kembali Bapak Dr. Wahyudi. Ini bukan ya orang asing bagi Fakultas Tarbiyah. Beliau dan lembaganya sudah melaksanakan berbagai program, ya, program di Fakultas Tarbiyah, dan yang ini adalah untuk tahun yang kedua. Ya, ada kegiatan yang sedang berlangsung juga beberapa minggu lalu, bulan lalu itu juga sedang ada pelatihan untuk dosen dan mahasiswa di Fakultas Tarbiyah. Terima kasih Bapak Dr. Wahyudi. Selanjutnya Bapak Dr. Khairun Sadami. Selamat datang Bapak, walaupun tidak terlalu jauh dari Universitas Siak Kuala. Mudah-mudahan kerjasama ini selalu dapat terjalin, terbina untuk memajukan kedua lembaga ini. Nah, selain itu juga ada Prof. Roberto Araya. Welcome Prof. Saya melihat sudah berhadir melalui Zoom meeting. Lalu ada Ibu Kristi dan Ibu Mayasari itu dari UIN Muhammad Yunus. Penghormatan kami juga kepada Bapak Dekan Fakultas Tarbiyah, sekaligus kami menyampaikan salam dari Bapak Dekan Fakultas Tarbiyah kepada kita semua. Beliau sangat ingin membersamai kita, akan tetapi sejak hari Minggu dan hari ini beliau sedang dalam perjalanan melaksanakan tugas negara ke Jakarta dan ke Bandung. Ya. Sepertinya beliau juga mengikuti melalui Zoom meeting, jadi karena beliau sedang dalam perjalanan itu tidak bisa memberikan sambutan. Begitu juga dengan Bapak Wakil Dekan 1 yang juga melaksanakan tugas ke luar kota. Selanjutnya Bapak Wakil Dekan 3 yang kami hormati sudah hadir juga bersama kita, Ustadz Mumtazul Fikri, Ibu Ketua Prodi Pendidikan Kimia beserta Bapak Sekretaris Prodi. Ini langsung tancap gas Pak Wahyudi dan Bapak Ibu sekalian, baru dilantik beberapa minggu yang lalu sebagai Ketua dan Sekretaris Prodi, langsung melaksanakan sebuah event yang sangat besar, International Conference. Ini tentu suatu prestasi yang sangat luar biasa yang diraih. Ketua GJM Fakultas Tarbiyah yang kami hormati, Bapak Ibu Ketua dan Sekretaris Prodi se-Fakultas Tarbiyah yang sudah berhadir pada kegiatan ini, Ustadz Takdir yang kami muliakan, dan Bapak Ibu peserta kegiatan International Conference Prodi Pendidikan Kimia, baik yang hadir langsung ke aula ini, begitu juga yang mengikuti melalui Zoom meeting. Selamat kami ucapkan kepada kita semua dan terima kasih atas dedikasi sudah mengikuti kegiatan International Conference ini. Ucapan terima kasih kepada seluruh dosen program studi pendidikan kimia beserta panitia yang sangat luar biasa dalam menyukseskan event ini. Dan tentu kami dari fakultas sangat mengapresiasi program studi pendidikan kimia sudah mampu melaksanakan 2 kali. Ini untuk yang kedua International Conference. Ya, walaupun persiapan lumayan lama waktunya, akan tetapi kalau kita bandingkan dengan yang pertama itu yang persiapan itu sangat membutuhkan waktu yang sangat singkat. Dan alhamdulillah Bapak Ibu sekalian, untuk tahun ini Fakultas Tarbiyah melaksanakan ada 8 event international conference itu pada tahun 2024. Dan salah satunya adalah yang dilaksanakan oleh program studi pendidikan kimia. Dan tentu kami mengharapkan dengan adanya event-event seperti ini, ya tentu akan terjadi penyampaian informasi-informasi yang baru, baik dari aspek pembelajaran maupun dari aspek perkembangan ilmu kimia. Tentu nanti narasumber yang sudah kita undang sebagai keynote speaker ataupun yang akan menyampaikan pada sesi paralel itu akan menyampaikan berbagai temuan-temuan dari riset-riset yang sudah pernah dilakukan oleh para narasumber yang mengisi kegiatan internasional conference ini. Dan untuk itu kami sangat mengharapkan ya kita semua ya dapat mengikuti kegiatan ini dengan serius sehingga kita dapat memperoleh berbagai informasi tambahan dan mudah-mudahan output dari kegiatan ini nantinya akan dipublish. Salah satunya itu mudah-mudahan dapat dipublish baik pada proceeding maupun pada jurnal-jurnal yang sudah ada di UIN Ar-Raniry ini secara umum dan khususnya mungkin jurnal-jurnal prodi pendidikan kimia. Yang kami ketahui di prodi pendidikan kimia itu juga sudah ada jurnal yang sudah terakreditasi Sinta 3 kalau tidak salah kami. Selamat kami ucapkan kepada seluruh peserta yang akan mengikuti kegiatan internasional conference dan sekali lagi kami ucapkan terima kasih kepada Bapak Ibu narasumber yang nantinya akan mengisi kegiatan internasional conference ini. Dan tanpa memperpanjang mukadimah, dengan mengucapkan Bismillahirrahmanirrahim dan seraya memohon ridha dari Allah, kegiatan internasional conference prodi pendidikan kimia saya nyatakan dibuka. Sekian, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Thanks to Bapak Samsul Kamal MPD for the welcoming speech and officially open the agenda. Ladies and gentlemen, this brings us to the end of our opening ceremony. I would like to invite Ustadz Takdir Ferizal SPDI to close this agenda with the recitation.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim wa 'azimi sultanik. اللهم صل وسلم على سيدنا محمد وعلى آله وصحبه وسلم اللهم أحسن عاقبتنا في عمور كلها وأجرنا من خزي الدنيا وعذاب الآخرة اللهم إنا نسألك رضاك والجنة ونعوذ بك من سخطك والنار اللهم اجعل جمعنا هذا جمعا مرحوما وتفرقنا من بعده تفرقا معصوما ولا تجعل فينا ولا منا شقيا ولا محروما اللهم اغفر لنا ذنوبنا ولوالدينا وارحمهما كما ربيانا صغارا ولجميع المسلمين والمسلمات والمؤمنين والمؤمنات الأحياء منهم والأموات
برحمتك يا أرحم الراحمين. اللهم ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. اللهم ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Assalamualaikum warahmatullahi wabarakatuh.
Thanks to Ustadz Takdir Farizal. Ladies and gentlemen, the next agenda is giving certificates of appreciation to our keynote speakers. I would like to invite Ibu Nurjahan Ahmad, MSc PhD, to come to the front. And following Ibu Jamil Suprihatiningrum, MPDSI PhD, to come to the front. And also I invite Bapak Dr. Hairun Saddami to come to the front. And also the last, I invite Dr. Wahyudi to come to the front. First of all, we would like to have Bapak Samsul Kamal MPD to deliver the certificate to our keynote speakers, accompanied by Ibu Sabarni MPD, and also following Bapak Teguh Badlisyah MPD. Then followed by photo session. Penyerahan cenderamata dari Universitas Sains Malaysia. Then followed by photo session, and also I would like to invite all of the lecturers to join the photo session. Sekali lagi Pak. Dimohon untuk kepada seluruh hadirin untuk dapat berdiri mengikuti sesi foto bersama. Thank you so much to Bapak Samsul Kamal MPD, Bapak Muntawizul Fikri, and also to our keynote speakers. Excellencies, to our keynote speakers, please have a seat back to your position. Ladies and gentlemen, now we have come to our main agenda is for sharing session with our keynote speakers. I'm the master of ceremony, handed it over to the moderator. I invite Mrs. Nurmala Hayati, MSc PhD, to take over the event. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Cek. Cek.
Oh,
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala asrafil anbiya'i wal mursalin wa ala alihi washabihi ajmain. Puji dan syukur kita panjatkan kehadirat Allah atas segala rahmat dan karunia-Nya sehingga kita masih diberikan kesehatan hari ini untuk bergabung di Second International Conference in Chemistry and Chemistry Education. Salawat dan salam selalu dipanjatkan kepada Nabiullah Muhammad sallallahu alaihi wasallam. Semoga kita selalu mendapat syafaatnya di dunia dan di akhirat nanti. The next session is the invited speaker. We will start with the first invited speaker, Professor Roberto Araya. Roberto, can you hear us? Or can you hear me clearly?
Yes, I can hear you very well.
Okay, but
so
before
I'm-
that, I would like to invite all the speakers here to join me in the stage. Nurjahan Ahmad, MSc PhD, Jamil Surya Suprihatiningrum, MPDSI PhD, and Dr. Khairun Saddami ST, and also Dr. Wahyudi. Please welcome to the stage. Hi, Roberto. Hi, Professor. Hi, Professor Roberto. How are you today?
I'm doing very well. Here is night, but I'm doing
Okay.
very well. Thank you very much.
Your voice is a bit low. I mean, it's not really clear with us. Probably the speaker can be a little bit high, probably.
Can you hear me now?
Absolutely, yeah. It's perfect now. Okay.
Right. And
What time is it there?
it's 10 p.m., 10:23 p.m.
Oh, it's night.
It's
Thank
night.
you for
I'm
joining
winter.
us. Okay. I will start with your CV before we listen to your fantastic research. Professor Roberto Araya is focusing in electrical engineering from the University of California, Los Angeles. He's professor of the Institute of Education of University of Chile. His research focuses on the design and measurement of the impact of teaching and learning strategies in integrated STEM. So for about 14 minutes, the time is yours. Please. Thank you.
Okay. Well, thank you very much for Nurma Hayati for the presentation. And I want to thank to the Dean Dr. Banda, the Dean of Faculty of Education, also for the invitation, and particularly to my friend Dr. Wayuri, that we have been working for, I think, more than a decade in CMEO and APEC project. So thank you all for this opportunity to share what we've been doing and also learn what you're doing. So I'm going to share my presentation. I don't know if I have permission to do this. Can I share? It says that hosts only. So, okay, maybe can you start sharing? So let me see. Oh, now I can share. Okay. Okay, just a second. Sure. Okay. Can you see my screen now? Can you see my screen? Yes?
Yes.
All right. Okay, good. So I'm going to talk about design and measurements of the impact of teaching and learning strategies in integrated STEM. I'm going to show in the process how AI and machine learning is helping in this challenge of integrated STEM. So I'm from University of Chile. Initially, I'm going to just very briefly explain where I am now. This is the other side of the world. So that's Chile. This is America, South America, and Chile is the green there. And this is the city where I'm very close now. It's called Santiago. That's the capital. And we have high mountains. The second highest mountain after the Everest. So we have very close to the city. So that's where we are. And now, if we want to go from Santiago to Jakarta, direct flight is 21 hours, but there is no such a thing as a direct flight. So normally it takes 2 days, because you will have to go to the United States or to Europe, and then, the whole process takes like 2 days. But it's been wonderful when I've been there in Jakarta and in Yogyakarta. And so we have a wonderful time with Dr. Wayuri, Dr. Sumadiono from Simulek, and from C. Kim. So it's a long travel, and I'm planning to go in October. We're working together with teachers, with Dr. Wayuri and Dr. Sumadiono in Yogyakarta, and I understand also in Bandung. So that's where I am. So now in the other side of the world, now it's 10:30 p.m. and it's winter. So it's completely different than where you are now, just the opposite of the world. So integrate STEM. And so I'm going to talk about why to integrate STEM. STEM stands for science, technology, engineering, and mathematics. So why we need to integrate? Because normally we teach students science like physics, chemistry, biology. We teach them mathematics. We teach them technology, and now we're starting to teach some engineering in elementary and middle and high schools. So, but why integration? Why do we need that? What are the challenges of integration? So it's a big challenge. It's not that easy to integrate all this discipline. I'm going to talk a little bit about this, and mainly I'm going to talk about activities and textbooks that promote this integration and very active pedagogy, dialogic pedagogy with projects for the students. So how we can do this, and also using technology like AI, get some measurement assessment, how the kids are, if the kids are improving. So that's the plan that I want to talk to you. So why integration, the challenge, activities and textbook. I'm going to show some activities with the students and measurements, and how then AI can help in this process. So first, why integrate? So, the main thing is that the real world problems need several science and engineering. You never see when in the real world, just a biology problem, just a chemistry concepts and ideas. You need the whole thing to understand the nature and to design solutions. And when you go to real world problems, then that's what you find. You need to, also start marketing also, some sales strategy, and design the product, solve the problem. So you need all kind of things. So the real world problems need everything integrated. That's how factories work, how industry work, and somehow we have been teaching everything isolated. But in the real world, everything is integrated. So that's the challenge. And for if we want students to try to tackle real world problems, and this finally boosts students' motivation. Um, most of the students like to work and solve real world problems. Only very small proportion are just interested in very abstract ideas or concepts. Most of them want to solve real world problems, and so this integration boosts students' motivation. So that's very important to recruit more students into STEM. When they see this is more applied and can solve real world problems, and you get more students interested in STEM. So that's why we need integration, because real world problems are because of students' motivation. And so what is the challenge here? Why is how to do this thing? First, one person the teacher and the students have to handle several scientific disciplines. It's not that easy. Say chemistry, and even or physics, and even in those areas, it's easy if you specialize in sub areas. To build solutions, you have to be efficient. You have to build a machine or build a factory to solve the problem. So you have two big challenges here. Several disciplines you have to know, and they also the engineering practices that are a little bit different from the scientific practices. They're not equal, and so you need all these two components. This is, for example, from the North National Academy of Science, United States. They have this STEM integration report in K-12 from kindergarten to high school, and this is not easy. So they have special reports several years ago, some directions how to do this. Yeah, and they say, okay, one way of doing integration is the following. Here you have in the left column, you have the mathematical curriculum, and the right you have the science curriculum of the United States. And there is a strategy to integrate this with models. I have highlighted in yellow that in both components you have use of models, mathematical modeling, models in science as well. So somehow the integration goes through modeling. So in both in math and in science, models, in different applied problems in mathematics, you need models, and also in chemistry and physics, in biology, you need models. So somehow modeling is the glue that helps to integrate. And here is just also at that time, the whole idea of how to integrate, how to construct and these models. So the cool thing is about using models, and I'm going to show some idea of modeling. That's the key of integration. So this is National Academies now recently have produced a new report for from preschool to elementary grades, so helping teachers how to do this. So 10 years after the previous report, now still is not something solved. Still, it's a challenge. So this is the National Academy that has science, engineering, and medicine from the United States, revising these strategies in order to help teachers to do this integration. And well, this is a CMU basic education standard that has mathematics and science that have been produced by CMU together with the University of Tsukuba, where is Professor Masami Sora, that we have been working with Dr. Wayuri and the whole team of CMU for several years, and they have produced this curriculum also that emphasizes this integration. So this a couple of years ago, this CMU basic education standards. And here is also another project we've been working, APEC, Asian Pacific Economies, Economic Cooperation, and they have this particularly this report that we have produced now with the whole new idea of integration modeling, but with computational thinking. So now comes, use the computer, not only modeling, mathematical modeling, but computational thinking. And that's where also machine learning and all this AI comes. That's what you see here in the left. You see here the computational thinking and AI. It's a new component now, but it's a new challenge for the teacher now. Also, not only how you have to integrate all the sciences, integrate with engineering, and do produce solutions, but also introduce computational thinking and AI. There are several barriers for integration when students nowadays they have a poor understanding of the core idea of each individual discipline. So how you want them to integrate everything when for each one we have some problems. The second barrier is the amount of knowledge in each discipline is increasing rapidly. The science is increasing the amount of things, so that's another problem. Third, the new concept of each discipline are not always intuitive. Some of them are very, not that simple to grasp. Fourth, there is a clear division of labor at school, like the science and also science department, math department, so they are isolated. Teachers need to learn how to discipline with integration between them. So that's something, something new for teachers. Teaching is a very conservative profession. I think teach as my teachers, taught. So this difficult to change, and it's still not clear how discipline gain a better understanding if integrated. So let's say you talk this with the math teacher to do the integration, and the math teacher would say, "But then it seems that they're not learning more math with this." So that's a problem. There is a structural isolation in this profession. They don't talk much. Each one teaching in his own classroom, isolated from the other classroom. So that generates a barrier. Teachers do not receive feedback about cross-disciplinary integration. Normally, the assessment that they're having some countries about teachers is just about their discipline, how they teach their discipline, not about the integration. And here is the final point I think was the most important one, and we've been working on this, is the lack of textbooks and material with integrated discipline. That's really, I think, number is the main problem. So we're working with this. Semiolex is working on this, and I'm going to show some ideas about this lack of materials. Okay, so I've seen why integration is needed and the challenge. Now I'm going to show some activities we've been working, some of them with Professor Wayudi and in APEC as well, with Professor Masami Soda from Tsukuba and in several other places. So activities and textbooks. Okay. I think thinking about chemistry, what are the main ideas of chemistry, since we are in a chemistry conference, chemistry education? One of them is that everything finally is composed by small particles, the particle nature of nature. So that's one very powerful idea. So finally, the atomic structure of nature. So I think this is something at the core of chemistry. But also, these basic components, basic blocks, these atoms, somehow they connect each other, and somehow when they are connected, there are new properties that each one of the initial components that didn't have that the initial atoms didn't have, so like molecules, and so this idea of emergent properties, I think that's probably one of the core idea of chemistry, this idea of emergent properties, from in this case from atoms to molecules, and then building more and more complex structures. So how we can explain this? So I'm going to show what we're doing with elementary school kids and then high school kids, and so in order to understand this emergency property. Let's say you have this boy here like this, could be a girl as well, can you balance without falling in this way? It's very difficult. Nobody can do it. No, it's really impossible. You know, the basic structure is a person cannot do this. It's impossible to just stay there in balance without falling. But so how can you model this? Let's say we model the person like with a paper this way. So we have this is a model. We cut it, and if we have like one person here, another person here, and you build this structure somehow. Now you put this four like atoms, each one connect with the other one. Then you get something like this, and now you can see in this case you have a model that has certain stability and have a new property. So that's what is here. Now it's a ambassador of Finland. So these are basically some textbooks. So we're now, as explained, textbooks are critical, and somehow we need material for this integration. So that's where we've been working. And you know, the history of text is that maybe the initial text were like the Sumerian tables, 2,000 years before the Christian era. There already have some stones explaining how to teach something for the kids. They want to be writers, scribes, those area. Then we have Ibn Khaldun in 1377, and talking about how to teach kids eloquence and cohesion. But the first really book for students was about Comenius in 1658. Was the first one that thought that children are not just adults scaled down to smaller size. So we need to produce text different than from adults, more active, more sensory images. So he introduced this whole idea. And after that, all of textbooks in Europe and then all over the world were somehow adaptations and based on this idea of Comenius, of this idea of textbooks that are different for kids. And what is called Orbis and Salium Pictus maybe was the first textbook for kids. It was translated to be a world of sensory images. Orbis and Salium Pictus was the name in Latin, but the reader was a passive reader, just reading what what the text said, and it's supposed to be each kid was isolated, so it was not project based, was not very active. We're proposing more like Orbis and Salium argumentation actors, means a world of sensory argumentation actions. So you have dialogue, you have to talk, you have to work with your peers and your classmates. So like the idea is that you write to others and receive the responses in the textbook. You have to write, scratch, paint your own textbook and send instruction to the other ones. And we're teaching like writing prompts in this textbook. So this is the idea. You have to write like prompts that you use in large language models. And the idea basically is a dialogical pedagogy where the most important thing is this do conversation, talk with your peers, and in order to work, not work isolated as was supposed to be the original idea. And still, in most of the you're supposed to work alone, not together with the other ones. And you don't have to write, you don't have to color, do anything. The idea is the truth is material. You have to actively do things. Okay, now I'm going to show what we have been working with Dr. Wayuri and with this Sumadiomo and the Simio, and also with the University of Tsukuba about coloring books to teach this some of the science ideas. So this is the typical activity. The kid have to read these instructions and do this small thing and then explain what happens. And then this is a page A. In the page B, the kid has just blank. The same is page A, page B. But in the page B now, let's say I have to write something for Wayuri. So we're both classmates. So now I write some prompts to him some instruction. Now we call it in machine learning, and he will have to solve the problem. So it's like I pose a problem. So we're using this pair of pages, but here you learn some ideas, some modeling, some way to do things, and you explain how you do it. But in the page B, you pose a kind of similar problem to your classmates. So that's basically the idea we have. Here's another one. It has to, for elementary school kids, they have to initially to do these instructions and explain how they did it. They have to color according to what they had to paint to color this activity. In the page B, now it's blank. Now one student, the other student have to write also similar problem to this. And the second student will solve painting, doing things, coloring, and then writing an explanation. So that's the idea. And then I'm going to show what we did with Dr. Wayurian Martino in Yogyakarta. I don't know if you listen to the music and the activity, but I will explain it. So the activity they're doing is the class in Yogyakarta, and they are initially doing they are then the second phase they will post the class. And so it's a for Wayuri, Martino. Then after that, when they finish, they have to explain the other class why they square. It's called Asami Soda from University of School. In case it's explaining how they do it, and everybody shared what was the solution. Now let's go to another example. Simple example. This is about taxes. Let's say you model the world like this board. In each of this is like the amount of nutrient in each cell, or the intensity of a smell, and then you have a dog that is moving from one cell to another one with a rule that you move to where is the more food or the highest intensity of smell. From 2, you will move to 10. From 10, you will move to 13. From 13, you will move to from 13, you will move to 21. From 21, you would move to 22. Now, this basic method is we call it the chemotaxis, but also it's called the steepest descent. This is the basic method behind all the machine learning programs. All about it's called basic optimization problem. It's called the steepest descent method. So the student have with instruction do this and then start coloring and producing the trajectory and then explaining. For example, you could ask here, let's say this is a dog that's starting to, and you will get to 21, 22, 30, 32 and get started machine learning, all of this problem now for applied mathematicians, the calculus, differential calculus to do this. The idea here was to translate to these basic core ideas in order that elementary school kids also can understand and use this algorithm, those basic idea. And what's interesting that, just 2 months ago, the Journal of Biochemistry and Molecular Biology, this professor from Molecular Technology Laboratory from University of Chicago, from Belgium, and in this article, they use this algorithm, the steepest descent algorithm. And when they say, we use this algorithm, and when they put their citation where to look for the algorithm, they say, okay, here you can find a very simple explanation of this algorithm, and they cite us this algorithm for kids, for elementary school kids. So somehow, even if professional chemists that and molecular biologists and biochemistry, when they're trying to explain this, now they see, oh, this was much simpler. The core idea is much simpler. So we're very happy that people like this also use this situation with this simple core idea of this deepest descent algorithm. Now, this we use this also for gastrulation. Gastrulation, when you connect to biology, I'm going to show you this. They have this model, like instead of it's a board, they have this like an egg. I'm going to explain to you. And also they have this, initially it's not a dog or it's not a bacteria that will move, but it's a cell that will duplicate and divide and start moving, in the gastrulation process when in the embryo. So, and here is the class. The kids are doing this activity. It's a lesson study of the teachers watching this, and it's the projection of like an egg with this amount of nutrient, and here's the initial cell. And so somehow this is an interesting way of integration of chemistry, biology, mathematics, and computational thinking, because it's a computational model and like board with numbers with rules of this process. So here you have the lesson, and the kids are answering some questions. They have chickens, they have eggs, they have to open the eggs, so it's biology thing, and they have to open eggs. They had an incubator there. They take from that incubator, they take the eggs. They have to think what's going to happen. They have to open the eggs, what inside, and when they look at it, see what happens inside. And now they're doing the computational model. This is the board like this. This is supposed to be a cell. And the cell is the duplication of the cell, then we'll move where it's more nutrient. So that's the basic model of gastrulation. They're doing this. So it's a way of doing the integration, biology, chemistry, chemotaxis with mathematical and computational modeling. Okay, and I want to announce that we have just produced a guidebook for unplugged computational thinking with some of this idea with Simio, University of Tsukuba, and me. We just produced the guidebook for teachers how to use these ideas. Okay, and finally, we have used also an app. So, once I do the coloring and write the explanation, so we would like to have an app that the teacher put there on the work the students have been doing, and transcribe this, put it on the servers, and then you have all the information and collect it, and that's what I show you. And for example, here is he wrote this in page B, and then somehow you put the smartphone. The smartphone then will translate this and understand what the explanation the student wrote, and then load to the server. So here is basically how this thing works. Then you look at the page of the student, it's the teacher with the smartphone, and from the smartphone, and then press a picture, and then press process, and then once when you, 1 or 2 seconds later, we produce it. It will translate all the activities that this is something that I did for Mr. Mastami thought, and to measure the argumentation if it's coherent or not. With this, we're using machine learning trying to automatically analyze what the kids are writing in these textbooks, and these are this answer to open question what they're writing, and see if it's coherent or not. And here also we're measuring this is the time, and here is what the board really was presenting. Yes, we have.
We will join for the
Yeah.
Because the time is, yeah. Maybe you want to close
Okay. All right. I finished. Yeah. So I'm the reference, and I'm finishing. I thought we will have 39 minutes. Okay. All right. So it's my presentation about the using the design and measurement of the impact of teaching and learning in integrated STEM. So thank you very much.
Thank you, very much, Roberto. I just want to ask one question. We just wondering that you wearing the batik, and it seems like when we see that your experience in Indonesia, it can be that the batik is come from Indonesia, because some of the audience also spot that you wearing the batik. And also we see Dr. Wahyudi in your presentation. So thank you very much. For the lesson learned, the insight, that's very good lesson learned for us, that we see that school from different places and also different states, including in Jogja. And the part interesting point is how we can learn and improve that the implementation process in the field still have a lot of barriers. And very interesting also when I saw that the ambassador joined the STEM, how you can do that. I mean, he seems enjoyed all the things when doing all the games. I mean, that's it's very good lesson learned, and so the student can see that even the ambassador can join and also enjoying all the moment when doing or practice STEM. For the next, we will open one question because we're considering that's your night there, that's your sleep time. But thank you very much for joining us here. Probably we will just open for one question before we go to the keynote speaker. Any questions, students, lecturers in Bahasa is okay? Probably you can also understand in Bahasa, Professor Roberto, because I see one of the model in Bahasa. Okay, Sylvie.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself first. My name is Sylvie Nabila. I'm the chemistry education student. Okay, so based on the explanation that I've hear and listen, so I want to ask one question. How the computational model of gastrulation works in chemistry learning? Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Sylvie.
And is one of the basic of ideas also in chemistry and biology. Idea is also true in mathematical modeling. In all fields using machine learning. So it's across ideas across several fields. Now in gas relation, what you have is that you have a model, model of an egg, and in each cell you have like amount of nutrients. And a very simple model is that you start with a cell that it divides, and then you have two cells, but then the new cell will put more nutrient. That's a basic, very simple model. Now, a more deep model needs more things. It's much more complex, but at least the basic core idea is that it's a combination of cell division plus this taxis. Taxis means motion. So it's a combination of the chemotaxis with the biological idea of cell division. So with these just two core ideas, you get to understand somehow how this, the embryo is start producing in the initial phases. So that's the cool thing. And the students, will get some of the idea. Now, when you analyze it, you will see also the limitation of this model. Somehow there is several limitations with the model. It's very important that the student discuss this and realize the limitation. One of the limitations that if you continue this, how are you going to produce different organs? Completely with different properties, different functions. This model doesn't produce this differentiation of different, and so you see the limitation, and this is very rich what to do and how to change this model in order to introduce this new component.
Okay, thank you very much. And before you leave, we have a certificate handed virtually. Who will? Rani, okay, please. In the process, a moment. Okay, thank you very much, Professor Roberto Araya. This is the certificate for the invited speaker. Thank you for joining us. We would like to have you here until the event finishes, but we also considering that your night time there. So thank you very much again to joining us, and see you again next time. Probably we can meet in person, not virtually, somewhere in Indonesia or maybe in Chile. Oh, October.
October, I plan to go and stay with Dr. Wayuri, and so I hope we can meet in person.
Okay. Okay. I think it's okay if you leave now. Yep. Thank you very much. Have a good night. Okay. Yeah. Yeah. Okay. We will go to the next keynote speaker. Here we have Nur Ahmad, MSc PhD. We will talk about leveraging EI, citation in chemistry and chemistry education. I will read a short of CV of her. Nurjahan Ahmad, MSc PhD, is a senior lecturer and also a chairperson for Bachelor of Science Education program at the School of Educational Studies, University of Science Malaysia. Welcome to Banda Aceh, Ibu. She holds a BSc in Biological Science from University of Pittsburgh, Diploma in Education from University of Science Malaysia in Chemistry, and also the PhD in Chemistry Education from University of Leeds. She's also the specialist and deputy director for the CMO Kampenang, and she had experience working with a lot of things in the Southeast Asia, Asia Pacific, Africa, and also Maldives. Today we will hear her experience about encouraging AI citation. Time is yours for about 25 minutes, please.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning everyone. Bapak-bapak, ibu-ibu, all the students, and not forgetting, thank you so much for inviting me to present some of my ideas and knowledge to share with all of you. All right, so the title of my presentation is Leveraging AI Chatbots in chemistry and chemistry education. All right, so what do we mean by leveraging? Who can answer? Okay, so we make it to the maximum. Yeah, use it to the maximum. All right, so I would like to ask some of you to give me the answer. Okay, if you know about chatbot, AI chatbot, okay, go to menti.com. Okay, I just give you about 1 minute. Put the code 490879007. Okay, name one AI chatbot that you like or you know. Yeah, yeah. Or you can scan from the QR code. Already. Thank you, Pak. I'll show you the responses. Okay, all of you already scanned? Or just go to menti.com and enter the code. Okay. All right, so I will show you the answer. Okay. All right, so I see ChatGPT. Yeah. Some of the words I'm not familiar, maybe it's in Indonesia. Okay. Okay, so the bigger the words, meaning that many people choose that. Okay. Okay, so ChatGPT, happy. Okay. Do you know AI chatbot? Who knows? Please raise your hand. Who know what is AI chatbot? I think you know, but maybe you don't know what exactly it is. Yes, I think you use it. You use it, but you might not very sure about what exactly. Okay, so the response ChatGPT, very good. Okay, that's a good example of AI chatbot. Okay, all right, good. Okay, so thank you so much for the responses. Okay. All right, so I'm going around, yeah. Okay, so this is the definition of AI chatbot. I'm not going to teach you about the definition, but let me just go down, okay, so you can see me clearly. All right. Okay, so AI chatbot is a software application, yeah. I think you have, maybe you have experience, you know, when you got responses from a robot, right? But that is conversational, conversational, meaning that it's a conversation. It will just respond to you. Maybe you just ask about the weather today, or you ask about, you call Siri, right? Siri, you have iPhone, so it's just conversational. Okay, so, but the one is a communication tool. It will respond to you from your text, or some you can even ask question, okay? But not so many using image. Okay, so it's an intelligent software. When we say intelligent, meaning that it has, you have set for it to be able to answer your question, yeah? Like human. Okay, so what I want to share with you today is generative. Generative means that it can create content. Okay, it can create, maybe you want to do your slides, PowerPoint slides, or you want to do quiz, yeah? You want to do quiz, so it will generate content. So sometimes it is known as smart teacher, virtual teacher, or smart tutor, or teaching assistant. Okay, so this can actually help us as teachers to make our life easier. You know, like make our job faster, instead of asking very simple question from students, we said, oh, why don't you just ask the chatbot? Chatbot can answer that for you. So we as teachers, we can focus on the more complicated or sophisticated question. All right, so there are a lot of studies have done on chatbot, AI chatbot. Okay, AI means what? What is AI? Artificial intelligence. Okay, good. Artificial intelligence. So, there are many studies. Okay, if you look at there are some studies here. So it shows that it will help the teachers to avoid repeating the work. You know, avoid repeating the work, and the students can be more self-study and they have autonomy. Yeah, they have autonomy in their learning. Increase the students' engagement and also foster critical thinking, problem solving, and many things. Yeah. All right. So this is some examples of the studies. Okay, what are we going to think about when we talk about AI chatbot? One is how we want to leverage the AI technology without replacing us as teachers. We don't want the teachers to replace us, right? Okay, so how we are going to use it to the maximum, but not replacing teachers. If not, one day you don't need teachers, we just need robot or just AI chatbot for the teachers. Yeah, and also how are we going to leverage AI chatbot in how we want to maximize when we do learn about content in chemistry, or in chemistry education, maybe you as teachers, you would like to further your studies, you want to do research. All right, so, and also I would like to talk about the advantages and disadvantages of AI chatbot. All right, so these are the examples, yeah, so please explore, because I'm just going to introduce one or two, but you can explore these AI chatbot tools. ChatGPT, very good. You know, just now you mentioned ChatGPT. Jenny AI, something similar, but Jenny AI is more on how you're going to write like a report or something. Popeye is a pop AI, yeah? Copilot, Research Rabbit, SciSpace, Consensus, Perplexus, Scholasy, Seaside, S-Site, Connectedness Paper. So there are even more in the market. They are also free. You need just to log in using your Google account. And also, but there are some that you need to pay. If you want to use it, the feature, sometimes you just need to pay. Okay, I'm going to show you. I think you know about ChatGPT, so I don't have to explain. All right, so ChatGPT can, what ChatGPT can do, it can explain a concept. It can even, let me show you how. Okay, I'm just going to show you how it will produce information. Okay. Okay, yeah, you see. You can also ask in Bahasa Indonesia, Bahasa Malaysia, or English. It will answer you accordingly. Okay, what is electrolysis? Okay, so it will give you the answer, right? Straight away give you the answer and also give you the picture. Okay. Okay, I want to try something else. Prepare. This is ChatGPT, slide 4. Okay, prepare slides for electrochemistry. Okay, so as teachers, we make our work easier, right? We want to make the presentation, but it just will give you the outline, but you need to develop the content yourself. Yeah, not fully given. Okay, and also the co-pilot. Yeah, you can for this one is Jenny AI. If let's say you want to write something, you just it will give you some citation. Yeah, so you can explore the one that I mentioned to you. All right, so okay, so there are many similar ChatGPT, Gemini, Copilot. It's just different with the branding. For example, Copilot is by Microsoft. Okay. All right. So this is the example of ChatGPT. Now it's 3.5 version, but you need to pay for version 4.0. Yeah, it has more features. Yeah. Okay, and this one, if you want to create quiz, you just write, create a quiz for electrolysis. It will come out like this. Okay, it gives you very easy, very quick. All right. Okay, so I'm just going to explain a bit about ChatGPT, what they can help you as a teachers, yeah, and also as a students. So ChatGPT can explain the concept, can give you some problem solving, some problems in chemistry. Tutor can be your tutor if you don't understand. And then it can also, it is very interactive. Yeah, you can ask question. Let's say you don't know about the naming of the chemistry, it can also give you the answer. You can also ask ChatGPT what's the technique for a certain experiment. And also, it will recommend some resources for you. Okay. If we compare, you look at Gemini. Yeah, Gemini, it has text and also figure. Okay. Compared to ChatGPT, only a lot of text. Yeah, a lot of text. So you can make comparison, ChatGPT and Gemini. Which one is better? Which one can suit you best? All right, so, and then there is a co-pilot. Yeah, there's a co-pilot. So, which is better? ChatGPT, Gemini, co-pilot. Which AI chatbot that you think better? If you have done it, if you use it. So, we have the findings, yeah, show that co-pilot is better. We have findings show that co-pilot is better than Gemini and better than ChatGPT. However, there's also study by Yi and Do show that ChatGPT is better. Yeah. So, which is better actually? So the question is, it depends on what you need. We cannot say ChatGPT is better than Gemini or Copilot. It depends on what you need, the content that you need. Okay, so because you can control it. All right. So, let's say you ask your students to do task or assignment. Okay. And this is also another AI chatbot that you can use. You just upload a paper, okay, and then it will show you what is the content. The main content will summarize to you, okay. So this is good if you are doing literature review, okay. And this one can generate from the PDF, okay. This is I show Jenny AI. Consensus, it will give you some papers that it will recommend good papers if you do your research. Okay, this is perplexity. All right, so with the generative AI, okay, so there's a problem with the assessment, especially for students writing. All right, so generative AI, they use a large language model, which is LLMS. Okay, so it tried to use as much as natural language as possible. For example, you asked about electrolysis. it will try to answer this in the scientific way. Okay, however, there is a concern about using this AI chatbot because of the academic integrity. Means that you can cheat, right? You can cheat and you can copy straight away. It will maybe cause you plagiarism, right? So there's a problem with academic integrity of cheating. So what is the action considered cheating? Yeah, so we have to consider cheating behavior may be the action. Straight away copy from what the chatbot already gave you. Okay, and also how the students evaluate the teaching behavior. Oh, this is not cheating. I got it from the AI chatbot, so they don't consider this cheating. So, however, the students, if they don't know how to write, they will have this motivation to start or to kick off doing assignments. So they will, I don't know, buntu lah, tak tahu buat apa kan, buntu kan. Jadi, you can use AI chatbot to start, to organize your ideas, yeah. So, there is an example of studies showing that in chemistry, okay, they ask the students they want to see whether how the AI chatbot in terms of the content of the organic chemistry. Okay, the assignment the students are asked to do is developing a therapeutic analog for thalidomide. Okay, the problem with AI chatbot is that they don't have much on electron movement feature, meaning that the content of AI chatbot still do not reach the level of human thinking when we do our reading, yeah, when we understand maybe the electron mechanism. The AI chatbot still do not reach our level of understanding. Alright, so the students is not able to reach the higher level of sophistication. Yeah, AI still not reach. So, that's why when the students or when we do the assignment, let's say you are S2 or S2, S3 kan, you have to do the research and report. So you have to make sure that you are guided by the integrity, academic integrity. Yeah, so you do not plagiarize. So what you can do is make sure that the content is accurate and recent. Yang terkini lah, yang terkini. Collaborate with the expert, maybe your lecturer. Okay, the expert, ask the expert whether the content is okay or not. Yeah, verify the content. Sorry, what happened? Okay, and then also you use the generative AI, as I mentioned just now, just to organize your ideas. Yeah, just to get some outline, okay, and for motivation to start your work. So you must make sure that you teach your students to be ethical when they get the information from the internet. So they have to cite the work. They cannot just simply use the word, yeah, use word by word. So this is the problem that we have right now, because when students submit their assignment, actually they copy everything from the AI chatbot. Okay, so we know because the wording, they are not, the flow and it's not consistent. So we can detect.
Ibu, apologize, the time will 5
Okay,
minutes.
almost finished. Almost finished. Thank you, Bu. Okay, so the advantages of AI chatbot is versatile. Okay, versatile, very quick information. You can assess very quick, very efficient, accurate, and there's a language support. Means that you can ask in Bahasa Indonesia, Bahasa Melayu, it will just answer you in the same language. But the disadvantages is there's lack of emotional intelligence, EI. And also some limited in the context, can be inaccurate. Is very, we have concern with the security, and also there's too much dependency. We too much depend on it. Okay, so my conclusion is generative AI, such as ChatGPT, it is going to give impact to our education. Yeah, it will always influence because it's a progressing. So you cannot avoid this. You cannot avoid your students to use this. But however, I still believe that it cannot replace us human or teachers, and also because it doesn't have human empathy. Ya, tak ada belas kasihan. Okay, itu saja. Sekian, terima kasih.
Okay, thank you very much, Ibu Nur Jahan Ahmad.
Okay.
Please have a seat, please. First, maybe the question answer we can explore more about these topics, yeah, in the end. So we will go to the second keynote speaker, Ibu Jamil Suprihati Ningrum, MPDSI PhD. We wait for her during to prepare the presentation. Okay, I will read the CV from Ibu Jamil. How I call you, Ibu?
Jamil.
Ibu Jamil. Okay. She is a lecturer at the Department of Chemistry Education, Faculty of Tarbiyah Teacher Education, Islamic State University UIN of Sunan Kalijaga, Yogyakarta, Indonesia, from 2007 until now. Welcome to Banda Aceh, Ibu. She obtained Bachelor of Chemistry Education from UNY, and then also pursuing the Master of Education in the same school, in the same university, and obtained Doctor College of Education, Psychology and Social Work in Flinders University in 2017. Her research is very interesting because it's focusing on inclusive science classroom. I think she has a lot of experience working with people with disabilities and also inclusive education. Today we would like to hear her experience, her sharing session about the machine learning for creating adaptive learning, especially in chemistry. About 25 minutes, time is yours.
Oke, baik. Terima kasih Ibu Nurma. Oke, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi wa sahbihi ajmain amma ba'du. The Honorable, the Head of Chemistry Education Department, Ibu Sabarni MPD, and Pak Teuku Badrisyah, thank you for inviting me today at this conference, and we're gonna discuss about machine learning for creating adaptive chemistry learning. So Ibu Nurma already introduced me. Basically, my expertise in science, inclusive science education. So I would like to highlight about the machine learning and how it can power the adaptive chemistry learning. Yeah, first of all, in this room or in the Zoom room, who has never used Google Maps? No one. I think everyone use it to find a new location, right? Gojek, Grab? Yeah, it's more convenient than traditional taxi. Yeah. Oh, Maxim. Okay. Yeah, the kind of application like Google Maps, Gojek, and Grab use machine learning. So they collect data from the users and then try to find, to analyze and then create something. For example, for the Google Maps, they can have like match and estimate the arrival time. Also the Gojek and Grab so match the riders with the drivers, and then the estimated prices like that. So that's kind of machine learning. Stanford University stated that machine learning is the science of getting computers to act without being explicitly programmed. So we use data-driven to allow the machine to learn and then give us a suggestion or a feedback or model or something like that. So it's a subset of AI which will deliver by Pak Hairun about AI. Yeah, but we're gonna not focus in the machine learning itself, but I will focus on the how it can power the adaptive learning. So again, machine learning is a subset of AI which uses statistical methods to enable machines to improve with experience. So the more data, they can learn much better. Machine learning algorithms can collect learners' data from various sources, including LMS, quizzes, maybe our SIAKAT, system academic, and then online platform, assessment, and digital resources. But in the educational field, we can use it for example, to design the curriculum, to recommend higher education courses to the students, and then to predict the student grades, and to create a student model for intelligence tutorial system. And now we're gonna highlight it. The one is called adaptive learning. So what is the rationale why we need adaptive learning in this era? We have to realize that our students are diverse. They have so many backgrounds, cognitive abilities, and then interests that we have to support the diversity. So everyone learns at their own pace. Adaptive learning is a technique or approach to use data-driven instruction to adjust and tailor learning experiences to meet the individual needs of each student. So this system can track data such as student progress, engagement, and performance, and use the data to provide personalized learning experiences. I want to highlight and repeat again about personalized learning experiences. So while equal education opportunity affords individual equal access to resources, equitable education recognizes and addresses the differences between the learners by providing the fitting material that align with each to reach their academic endeavor. So the adaptive learning itself, along with adaptive teaching, adaptive assessment, will strive to provide equity in education to all learners, including students with disabilities. So this one, like the illustration how the adaptive learning work.
Adaptive learning describes the process in which the learning path responds to the student's performance and adjusts to help facilitate learning in real time. Adaptive learning holds the potential to give every learner their own personalized learning path, customized and fine-tuned for his or her own unique strengths, weaknesses, goals, and learning style. With every action taken, the curriculum responds to keep the learner actively engaged in a way that is optimal for that individual student.
Excuse me, it's technical problem.
Adaptive learning describes the process in which the learning path responds to the student's performance and adjusts. personalized learning path, customized and fine-tuned for his or her own unique strengths, weaknesses, goals, and learning style. With every act. What we mean when we say adaptive learning. Adaptive learning describes the process in which the learning path responds to the student's performance and adjusts to help facilitate learning in real time. Adaptive learning holds the potential to give every learner their own personalized learning path, customized and fine-tuned for his or her own unique strengths, weaknesses, goals, and learning style. With every action taken, the curriculum responds to keep the learner actively engaged in a way that is optimal for that individual student. While the general principles underlying adaptive learning are not new, it is the advancements in technology that have made adaptive learning scalable. By providing a rich level of data on every individual learner, a teacher is now able to more fully know how close each student is to showing evidence of proficiency. Utilizing technology-driven personalization, adaptive learning holds the potential to fully extend the benefits of one-on-one instruction to every student in the classroom.
So that one is how the machine learning can use to create the adaptive learning. In the chemistry education, adaptive learning system leverage measuring the learning pathways. So the technological advancement like AI make adaptive learning easier to implement. So adaptive learning is not a new approach. It's been discussed for decades, but with the new era, the new technology like artificial intelligence make this easier to implement. So now, because they can convey educational information and changes to meet the requirements of certain students, like, for example, students with disabilities. Okay, yeah. It has three areas. The first one is content. So the content provides feedback to the student-specific responses, like hints, review materials on the relevant skill, and then further scaffolding without changing the overall sequence of the skill. So we don't have to change the sequence of the competency that our student to obtain, but we can provide feedbacks in time feedback. And then the second one is sequence, continuously collects and analyze student data to automatically change what a student sees next. After that, the third area is assessment. So this one changes the question as a student sees based on his or her response to the previous question. So for example, the difficulty of question will increase as a student answer them accurately, but if the student struggles to the question, so the question will get easier for the student. Therefore, actually adaptive chemistry learning will break down course materials into manageable sections based on each learning objective. So we have to chunk the information, we have to provide small courses, and then we have to give the learners with immediate assistance, resources specific to their learning needs and the relevant feedback. And then the software, the machine, will adjust the content, the sequence, and the assessment according to the interactive responses stored in the system. So this one, so it's how the machine learning works. Instructors can adapt instruction by making just-in-time, data-driven, informed decision to cater the course to each individual needs. Now, this one, the scenario that we can have as instructor or teacher or lecturers. So the first step is we develop objective-based small knowledge units or short lessons. And then the second stage, we develop assessment and feedback. And then the last one, we design the adaptive learning paths. So we have paths or jalur gitu ya, to make each individual learn by their own way or their rhythm. This one, some examples of adaptive learning platforms you can explore in the Google. For example, SC Training, formerly at App, and then we can use 360 Learning, Wordfig, Adaptemy, Newton, and others. But unfortunately, all of them are paid. Yeah. So the last one, what is our roles if we create or if we use or if we implement the adaptive chemistry learning? The first one, we have to support our students in building their portfolios and honing their problem-solving skills. We have to provide the students with feedbacks, because our feedbacks will guide or will give the machine learning to learn the possibility, and then they can suggest something to the students. The second one, we can predict the students' performance and can also classify confusion levels of students, whether a particular topic will be clear to the cluster of the students or not. So our role can be divided by two. One is support and the other one predict. Okay, the next one, is it important to use machine learning to create adaptive learning? That one, some of the benefits of machine learning to power the adaptive learning. The first one, as I mentioned before, it can personalize learning experience and pathways. So everybody has the equal access to resources, to learn, to do something. And then the second one is a dynamic recommendation of supplementary materials, and then optimize learning path, and then to rapid adaptation of learner model, to enhance recommendation system and targeted learning material delivery. And then efficient clustering of learner for tailored strategies, and identification of learning styles to improve is one the benefit of machine learning. But on the other side, we also have big challenge. The first one, of course, data, because machine learning learn by data-driven. If we have just a little or not sufficient data, they can learn better. So it's very depends on the learner's data. And then the second one is it's related to data privacy and security, and then the complexity of combining multiple machine learning techniques, and then integration and compatibility with the existing, it's ready or not yet. And then we need for example, ongoing training and updates to machine learning models, and then developing, integrating, and maintaining AI-driven system can be very expensive. And last but not least, as Ibu Jehan mentioned, is about the human aspect of education. So over reliance on technology always a risk of neglecting the human aspect of education. Thank you so much for your kind attention. If we need further discussion, we will in the last session. Thank you so
Okay.
much.
Thank
Assalamualaikum
you very
warahmatullahi
much.
wabarakatuh.
Ibu Jamil, very interesting insight. Okay. Now we will move to the next keynote speaker, Dr. Khairun Sadami. Should I call you Khairun? Yes. When I saw your research, I just remember Pak Khairul Munadi, and then I just scrolled the.
He is my professor.
Oh, that's why. Now he is in London, working with the KBRI London. That's why I know him for some projects. So when I saw that your research about the image processing, I just remember this is Bu Fitri or Pak in Syah Kuala University since 2000 and 2000. And his research interests are document image analysis, deep learning, biometric and biomedical image processing, and pattern recognition. He has a lot of publication on the area of the interest, very interesting. And today, he will talk about document image analysis. Sorry, I think that's your interest. Maybe you can share with us about your experience and also how the technology involved in the learning.
Yes.
Time is here, about 25 minutes. Thank you.
25. Yes, for the operator, please show my slide. Did you have my slide? It's okay. Is if you okay? Yes, yes. Okay. Assalamualaikum warahmatullahi wabarakatuh. I'm sorry, standing here. Alhamdulillah, alhamdulillah rabbil alamin. Allahumma salli wa sallim ala sayyidina Muhammad wa ala alihi wa sahbihi ajmain. All praises be to Allah, the Lord of the world, the master of the day after. Peace be upon to our Prophet Muhammad sallallahu alaihi wasallam. Okay, before I start the presentation, I would like to introduce myself. My name is Khairun Sadami. I'm a lecturer at Universitas Syah Kuala. My educational background, I obtained my Bachelor of Engineering in 2015 and my doctoral in Computer Engineering in 2020. My research expertise and research topics is deep learning, pattern analysis, and machine intelligence, artificial intelligence, and medical image analysis. So, who want to corresponding with me, please send the correspondence to my email, khairun.sadami@usk.ac.id. Okay, my research, my presentation today is deep learning for conducting research in chemistry and chemistry education. So, I think it's a little bit weird. I stand today in front of chemistry teachers, chemistry student, and chemistry lecturer. But it's okay because before I joined computer engineering department, my expertise is chemical chemistry, and one of my best teacher in chemistry at high school is Mr. Fadlian Shah. Give a plus for him. I'm very excited he attend this conference, and before previously Professor Nurhan and Professor Jamil talk about machine learning, AI for chemistry and chemistry education. Now let's we talk deeper and advanced, more advanced, what is artificial intelligence. Thank you, Ms. Nurma. Artificial intelligence timeline. So, artificial intelligence started at 1930. Several researchers try to make a program that can learn just like human. How to make a machine in this computer that can learn, can so after that, in 1918 and to 2012, machine learning became the most artificial intelligence field that it's okay. I make my slide by myself, so I remember what I have to talk. Okay. So, machine learning, just like superfactor machine and neural network that inspired by human nervous system, is proposed, is developed. And then in 2012 to 2022, deep learning became very popular. And now, generative AI. And now, generative AI is the most popular technology that adapt in every single of research. Okay, now we talk about what is artificial intelligence. How artificial intelligence is built, is proposed. How artificial intelligence can do what human can do. Why artificial intelligence have better performance than human. That's a big question. How to for aspect in artificial intelligence, we have to make the computer or a machine think humanly. So we build several programs, several method, algorithm that make the machine, the computer think humanly, think like human. On the other hand, the artificial intelligence, the machine, the computer think rationally. The computer didn't have emotional aspect. The computer didn't have affective aspect. They just think, act rationally. But we are the human being. We think humanly, we act humanly. Because emotional side, we have emotional side. We have the religions, the art, the thing that can be programmed yet. Okay, so the artificial intelligence to make computer, to make machine think humanly and think rationally. So when the computer think humanly, it's also think rationally, and acting humanly, acting rationally, acting like human, but also acting rationally. Next, please. Artificial intelligence is a broad field that consists of several type artificial intelligence system, such as expert system, fuzzy logic, and meta-heuristic search. And one of the artificial intelligence subtopic of subfield is machine learning. Okay, machine learning to make the computer to learn like human learning. And the advance of machine learning is deep learning. Make the computer, make the machine get more data and train more specific tasks. Next, please. Okay, deep learning is developed based on neural network. Neural network, a system that adapted the human nervous system. So we are just like human, yes. We are human being. Our sensor feel something, and then the information is delivered to neuron system, and the neuron system deliver the information to the brain, and the brain give the action to our bodies. Next. Okay, what is machine learning? Please, next. Okay, machine learning. The term learning in machine learning is any process by which a system improves performance from the experience. So we just make the computer can improve their performance based on previous data. So a machine that learns from the data and generate a model to solve certain problems. So just like the student, they choose the department because they want to be an expert in that field or in that area. Okay, make it simplify. The machine learning process, we have the data, we ask the machine learning, the algorithm, the technique to learn the pattern from the data and makes the model predict the future or predicts something what we want to result it, and using the model based on the future data. Next, please. Okay, three most concept of machine learning. Machine learning just like the student. We are the lecturer or the teacher treat the machine learning or the machine or the computer just like this. The lecturer, the teacher treat the student. When we teach in front of class, okay, we give some formula to the student. We give some concept to the student. Yeah, we give some data to the student, and after that we give some example. After we give the formula, we give some data, some information. We give the example, the exercise. After that, we answer the exercise, for example, for the student. And then, in the middle of class or at the end of class, at the end of the semester, we take the final test to assess how the student learned during the class. So machine learning do the same. Okay, we ask the machine to learn the data, and then we give the example, we exercise in the end of class to assess how good the student perform during the class. Okay, next please. Okay, the specific machine learning. Machine learning needs or requires suitable attributes. So the computer did not understand the image, the character, just like the human. But the machine or the computer just understand 0 or 1. They are machine programming. They are only now, yes, attribute of 0 or 1. So we need to assign suitable attribute to get the best model, to get the best machine learning performance. But machine learning, we don't need the machine learning to calculate something. For example, we do not use machine learning for payroll calculation. So how much payroll we get in a month, we don't need machine learning to calculate. So use machine learning in term that we want to predict the future thing based on the previous data. Next, please. Okay, in 2012, deep learning is exploited. It explodes because, next please. Okay, because machine learning has to be more advanced due to the machine learning is more related to human being. So we need the machine, the computer we build is more related to human being, acting like human beings. However, the deep learning require more resources. So when we build a deep learning model, we require more resources, more data, more computation for build the model. And deep learning has black box system. So we didn't know which specific algorithm that influence the result or the system. Next, please. Okay, deep learning breakthrough start from gradient base by Jan LeCun. In this purpose, the AlexNet win and beat the human performance in 2012. Residual layer is proposed in 2015, and attention module, which is the transformer-based model, and this transformer makes ChatGPT successful in beating the human being. Next, please. Okay, there's several tools that can be used to program the deep learning and machine learning. Okay, next please. Okay, this is the ChatGPT. This is how the ChatGPT perform. So behind the ChatGPT, Prof. Nurjahan and Prof. Jamil show us how to use the ChatGPT. So I will show you. This is how ChatGPT works. Okay. So we have the text known as prompt engineering. We have the prompt or the query, and then the query translates into a number. The number processed by transformer, the deep learning, and transformer retranslate to the number, and number retranslate to the word or to the prompt, to the result. That's how ChatGPT works. Next, please. Also, deep learning used for medical system. So we have smart watch that measure our heart rates, our heart. Then the measurement is translated by deep learning to the adjustment. So we have the measurement of our body system. Next, please. And this is deep learning for ITS, Intelligence Transport System. Next, please. Okay, this is some of biggest AI technology company in Indonesia. Next, please. Okay. Now we are going to deep learning in semester. Okay. Okay. How can deep learning, a computer-based, can be used in chemistry or chemistry education? The answer is the pattern. The chemical compound, the chemical molecular, has the pattern. The pattern in the molecular compound is learned by the deep learning. The deep learning would learn the pattern and find the characteristic of the chemical compound, molecular compound in the chemistry. Next, please. Okay, here is some papers, not mine, yes, not mine, but several papers that use deep learning for chemistry research. Next, please. Okay, do the time we skip the explanation of this paper. I will show you several excited results. Next, please. Okay, this paper by title enabling late stage drugs diversification. So this paper create new drugs based on deep learning. So they use deep learning to find a new drugs based on geometric deep learning. So they use the deep learning, they predicted, they done some training, and then they successfully find the new drugs based on the previous information. Next, please. Okay. Okay, this is another research that use deep learning in student engagement in e-learning environment. So when we teach the student, I am the lecturer and the teacher, we want to our student engage in explanation or in our but sometimes it's not happen because of several reasons. So by deep learning, we can engage, we can make the student engage to our learning environment by mapping what the topics is, makes the student engage us, what the material, when the schedule of our teach, that deep learning can mapping it and give us the conclusion, how can we study it, what material that most excited from the student. Next, please. Next, please. Okay, stop. Okay, maybe the last papers I would like to show you is deep neural network in chemical engineering classroom to accurately model absorption equilibrium data. I forget what is model absorption equilibrium, but they use deep neural network to simulate the experimental process. So when we have a chemical class Yes, we have to do several laboratory experiment. But by this paper, they build a tools box, they build a system that can modeling, that can simulate, yes, the experiment by using the computer. And it's done by using deep learning or deep neural network. Okay. Next, please. And next, please. Next. Next. Okay. The future or opportunities. So we are in chemistry and chemistry education. We have several issues in deep learning model. Yes. The research just began in chemistry and chemistry education. So we have a very broad area to research about it, to research, to implement the deep learning. The things that we have to do is to learn the AI skills. We are from the chemistry and chemistry education. We don't have to understand what AI is, but we have to understand how to use the AI. Just learn how to perform, how to build AI model, and we can explore very much in chemistry and chemistry education. For example, professor in front of us use the AI for chemistry and chemistry education. Next, please. Okay, next, please. Habis. Okay, the conclusion, deep learning already very strong in terms of theory. So the theory of deep learning is very, very strong. So we don't have to explore more about the theory. But now we have to focus on implementing the deep learning in chemistry and chemistry theory. And we can also use the deep learning to see the effective side of students regarding of learning process. And I think that's all from me. Thank you for your attention. I give back to Prof. Norman.
Thank you very much, Dr. Khairun. We can see the broad of range of use of AI, how it can help to discover new drugs. That means that help a lot of people. So we don't need to wait with all the system, and it can help to process, to help the process quickly. I think there's a lot of positive thing also that we can learn from your presentation. Thank you. And the next speaker is Christy Morhos. Christy, are you there? Christy, can you hear me? But you cannot.
Yes, I can hear you. Can you hear me now?